In this demo, we'll implement data shaping for a single resource. We're going to need another extension method for that, this time on object instead of on an IEnumerable of object. This might seem redundant at first. Why not just write a shaped data method on object and reuse that for each object in an IEnumerable? There's a good reason for that. We'll get to it soon, but first let's add that new extension method. So let's add a new class, Object Extensions. And let me paste this in. It's going to look very familiar. It's almost the same as our existing shaped data method. So this is a shaped data method on something of type tSource, which returns an expando object and accepts a nullable string of fields. We first check the source. If it's null, we throw an argument null exception. Then we look at the fields property. If it's null, all public properties should be returned. So we get the related property infos. This time we don't store these property infos in a list. There is only one object we are working with here, so we have no list of inputted objects to run through. There is no performance benefit in storing the property infos. After we got the property infos for all fields, we run through them and we add the related property value to our data shaped object, much like what we did before. Afterwards, we return that data shaped object. If the fields parameter contains values, we only want to return the matching fields. So we split the fields on a comma and we run through them. After trimming them, we get the related property info for each field, and then we use that property info object to get the related value on the source object. We eventually add the field to the expando object, and after we have run through all the fields, we return the data-shaped object. And that's it. Now, why do we have these two extension methods? One on object and another one on IEnumerable. Why not simply call this shaped data method we just created for each object in our author list? Let's put our previously created shaped data method next to this one. The reason is performance. As explained when we implemented the shaped data extension method on IEnumerable of tSource, reflection is expensive. In our shaped data method on IEnumerable of tSource, we get around that by saving a list of property info objects. Afterwards, we then reuse those property infos for each object in the list. Were we to use the shaped data extension method on object for each object in the list of authors, we'd have additional reflection for each object. By creating two extension methods, we avoid this performance impact. Alright, so far for that. Let's use this method. Let's open the authors controller and let's scroll to the getAuthor method. The first thing we want to do here is allow passing through the fields we want to see returned. We don't need a containing class like authors resource parameters this time. There's only one that can be passed through next to the author ID, which is coming from the route, and those are the fields. Here too, we're now no longer returning an author DTO. So let's switch this to IActionResult. And right before we return the author DTO, we shape it by calling into shapeData, passing through the fields. Alright, let's give this a try. I've got a request lined up here that shapes one specific author. It should return the ID and name fields. And there we go, that works as expected. Interesting fact here, by allowing data shaping, we could potentially violate a REST constraint, the manipulation of resources through representations subconstraint. That subconstraint states that when a client holds a representation of a resource, including any possible metadata, it should have enough information to modify or delete the resource on the server, provided it has permission to do so. We're currently not completely adhering to that yet. We're just returning an ID. And to adhere to it, we should either include the resource URI in the response, or better yet, support HateOS. That's coming up in the next module. But let's imagine we don't want to implement HateOS, which is still pretty common for APIs. And let's say that we feel that returning an ID instead of a full resource URI is okay. And let's imagine that ID here is the identifier. We can send this request only asking for the name to be returned. That'll work. But this can't be good. Without the ID or the source URI, we are not adhering to the subconstraint. So I just want to mention this here because not all APIs support HateOS. And if you don't want to do that, and you're opting to add the resource URI to each response, make sure that you do not allow data shaping to omit that resource URI. And this kind of proves that it's not always that simple to adhere to these constraints and design a truly RESTful system. Before you know it, you introduce functionality that breaks our architectural style. Anyway, that's something to keep in mind. There's two more requests lined up here. The first one tries to data shape an author by requesting the first name. Let's give that a try. We get an error. That makes sense, as first name is in the field on the author resource. And let's try the same for data shaping the authors instead of one specific author. We get a likewise result. So this kind of makes sense, as first name is in the field on the author, but the response we get is a 500 internal server error. And that is not right. This is a client error, so that warrants a level 400 error, just as it did when we were sorting our resource collections. Let's learn how we can fix this. To correctly implement the HTTP standard, we need to return a level 400 error, like a bad request, when the client makes a mistake by inputting an invalid field to shape. We're looking at the getAuthors method. Theoretically, we could reuse the check we previously wrote for checking the order by clause. However, that wouldn't be correct. It'll work because we stated that we need a mapping for each property. So for all fields on the DTO, mappings will exist. But our data shaping component doesn't use that mapping dictionary. So if you have a resource collection that supports data shaping but not ordering, well, you're out of luck. And it's also definitely not a good separation of concerns. Thus, it's best to keep these separate. What we need to check for is that for a given string of fields, all properties matching those fields exist on a given type. Let's create a service for this, so we can use ASP.NET Core's built-in dependency injection mechanism. We want this to be reusable and injectable wherever we need it. Let's name it Property Checker Service. We'll add one method to it. Type has properties. It returns a boolean and it works on a given type, T. So, what does the implementation look like? It's much like our shape data method, so let me paste that in. There's not much new here. If no fields are passed through, we can safely return true. If fields are passed, we split the field string and we run through all the fields. We trim each field and try to get the property name. And we use the getProperty method to check if a property with that property name can be found on the inputted type. If one can't be found, we can already return false. If all checks out, we can return true. And that's it for that method. Now let's extract an interface for this service. We can do that by right-clicking and choosing Quick Actions and Refactorings. Here we choose Extract Interface, and automatically the Type has properties method has already been selected. So let's click OK. Property Checker Service now implements iProperty Checker Service. And if we have a look at that interface, we see that it contains this one method. And let me clean this up a bit. There we go. Now we can register our property checker service on our container. Let's switch to the configure services method in our startup helper extensions. Just like our property mapping service, this too is a lightweight and stateless service. So transient is a good lifetime for this. Back to our controller. Let's inject our service. And while we're at it, I'm also going to inject a factory to create a problem details object. That's the problem details factory. This is defined in Microsoft.ASP.NET Core.MVC.infrastructure. As you remember, we want to return something of that type when something goes wrong. The factory helps us create that, and it offers more flexibility than simply returning a bad request like we previously did. So, we're in the getAuthors method. Here we call into type has properties on our property checker service. If it returns false, we return a bad request. And this time we use the problem details factory to create a problem details object. That's in line with the problem details RFC we previously looked into. It allows us to pass through a bit more detail than simply returning a bad request like we previously did. So now you know about 3 different ways to work with these types of problem details. Simply using one of the helper methods on the controller base, which is done by returning a bad request. Extending that by using a problem details factory to create a problem details object that allows you to customize the content of the bad request response. And if you remember from a previous module, in the courses controller we returned validation problems. That's a specific implementation of that problem details standard. And we even learned how to customize this and reuse that customization by overriding the validation problem method on the controller base. So there's quite a few things you can do here, and depending on how far you want to go with it, you can use one or the other or both. Anyway, we're back in our authors controller, and we now have a check in our getAuthors method. That means that we only need one more check, and that's in the getAuthor method or action. And there we go. We add the same type of check, this time on the fields parameter. Let's give this a try. Let's try getting the first name of one specific author. This now fails with a 400 bad request with some more detailed information in the response body. And then let's try getting an author collection, data shaped by a first name field. And here too, we get our customized 400 bad request response. Let's have a look at the other options we have with data shaping. There are a few additional pieces of functionality we could implement on our API. The data shaping principle can also be used to automatically include child resources. One option would be using a new expand parameter combined with the fields parameter. Another option could be incorporating this into the fields parameter. If it includes a field of courses, it should include the courses collection. Something else that's sometimes seen on APIs, not related to data shaping directly, is using more complex filters, like a contains filter. This should then return all types of authors that partially match the filter, instead of only exact matches. The more of that we allow, the less we might need searching functionality, and so on. If you want to implement something like that, you can build upon what we did in this and the previous module. But think well about how you want your API to be used. There's no need to implement all of this functionality if it's not something you'd expect consumers of the API to require. After all, some of these things do take a bit of time and thus money to implement. Just remember, pass parameters via the query string and only use fields that are part of the resource